We'll take a look at the ownership and ownership strength QoS policy. The ownership QoS policy basically specifies whether or not a data reader can receive data from more than one data writer at the same time. By default, ownership is shared. Shared ownership allows a data reader to receive data from any data writer of the same topic. So here we have an example. We have 3 data writers. If each data writer sends data, the data reader will receive data from all the data writers. You can set ownership to be exclusive. Exclusive ownership allows a data reader to only receive data from a single data writer. So this is very useful if you have 2 applications. One is a primary, one is a backup. You want the data reader to only receive data from the primary application, or actually just one application at a time, whether that's a primary or the backup. Certainly if the primary is alive, you want it to receive data from the primary. But if the primary goes down, you want the data reader to receive data from the backup. So here we have a case. Here's the top one's the primary, and these other 2. If the other 2 applications, other 2 data writers try to send data, it will be rejected, as in DDS will not deliver it to the data reader. Only one data writer can be the owner of that topic at a time. So, how do we configure who is the owner? Well, we use a related QoS called ownership strength, and this basically configures the data writer that will own the data when the ownership is exclusive. So fundamentally, data readers will receive data from the highest strength data writer. Okay. Now, one of the questions we always get is what happens when 2 data writers have the same strength? Well, DDS will use an arbitrary but consistent algorithm so that all data readers will receive data from the exact same data writer, but it's fairly arbitrary, so you cannot kind of determine that. If you really want to determine which data writer is the owner, you really need to set the strength to be different. So here's an example. I have a single data writer, it's strength 1. If you have a single data writer, then of course you'll receive data from that data writer. And don't forget, ownership right now is set to exclusive. But if we start another data writer and its ownership strength is higher, let's say 5, okay, then the data reader will receive data from that data writer. If the data writer with lower strength, any strength less than 5, the data reader will reject that data. As in, you're not even going to see it in your application. We will reject it for you. DDS will reject it for you. However, if the higher strength data writer goes away, okay, then after some expiration, after some timeout period, set by deadline or liveliness, or the data writer actually tells everyone, hey, I'm going away, at that time, a lower strength data writer will take over ownership, and then a data reader will start receiving data from the lower strength data writer. So the ownership and ownership strength QoS policies are configured by kind. Kind can either be shared or exclusive. By default, it's shared. Okay, and then ownership strength is used when you have exclusive ownership, and it's integer, and then we just compare who has the highest strength. You may have multiple data writers for the same DDS topic. You may have redundant sensors, so maybe redundant command consoles, and you're operating in a hot-warm design for primary backup. So your backup application may be running, or maybe waiting, maybe up, but waiting to run. So ownership and ownership strength is our QoSs that can be used to help you design your system when you do have this kind of configuration and requirement. You cannot change the ownership kind, but you can change the ownership strength. So as you're running, you might be able, you are able to change the strength so that maybe you come up with a lower strength, and if you want to take over, you change your ownership strength to be a higher strength, and all of a sudden that application is now becomes the owner of that topic. Ownership is RXO. It is something that's requested versus offered, so you must actually be the same. If the data writer is shared, the only way that you will match is if you also have shared ownership. If the data writer is exclusive, then you must also have exclusive ownership as a data reader. So it must be exactly the same on both sides. Now, some of the details. Ownership strength is only configured for the data writer, and all the data sent by a data writer has the same strength. This information isn't propagated with the data. Once we discover the strength of the data writer, we assume all the data sent by that data writer has that strength. Now you can change the value of strength, but the change is propagated as discovery traffic, and it's not attached to the data sample. So data readers will immediately receive data from a new data writer with higher strength. So if a data reader discovers a new data writer with higher strength, it'll immediately switch to that data writer. So basically you can kind of use this concept to take over or override the source of a topic. DDS will automatically switch to the next highest strength data writer when the highest strength data writer is deleted or it dies. Basically after a timeout period, it dies, and at timeout, we time that data writer out, we'll switch. If you delete a data writer, the deletion event will be propagated to everyone, and then once I find out that you've been deleted, I can switch, a DDS will switch over to a lower strength data writer. But timeouts can be configured to be faster than detecting that the data writer is dead. Timeout could be detected when the data writer stops sending data. So if you use deadline or liveliness QoS, if either the deadline or liveliness QoS times out, the period times out, or the data writer loses its liveliness, then the ownership will be transferred to the next highest data writer. So for high availability, again, I want to emphasize that this is not a complete failover solution, but it can be useful in creating such a solution. Ownership can be used to switch quickly from a primary source to a backup source if two applications are both sending out command data, okay, but your system is designed to only receive a single stream at a time, not in both. You can use ownership strength, and that's certainly the fastest way. If both the primary and active are sending out, or the primary and the backup are both sending out a command stream, and the primary suddenly fails, well, there's really nothing that needs to be done because of in terms of application logic, because the backup's already sending out its data, and DDS can very quickly switch between the primary source and the backup source. More often than not, you might be running in more of a hot-warm, where the primary and backup applications are both running, but the backup is in a backup mode, and it's basically going to only start publishing when it detects the failure of the primary. But still, in this case, using ownership strength can be very useful, because in many systems, it's not expected to receive commands from multiple sources, and you really need to guarantee that only one source is able to send the command, or you're only going to receive the command from one source at a time. Now, notice there's no guarantee that all the data is received during failover. You're sending a sequence of data. You're sending out data value 1, 2, 3, 4, 5, 6. There's no guarantee that you're going to receive 1, 2, 3, 4, 5, 6, even if both the primary and backup are both sending data at the same time, because it does take some amount of time to detect that the highest strength data writer has failed. And during that time, even though we're receiving data from the lower strength data writer, because we still think the higher strength data writer is still alive, we'll probably be rejecting the lower strength data until the timeout has occurred. So unless the timeout occurs faster than how fast you're sending out data, no matter what, we're not guaranteeing that you're going to basically get all the data during this failover process.